Hi, this is Tom Kaler with CrowdSmart and Common Good AI. And this is a first of a series of videos on generative collective intelligence, specifically, however, the implementation thereof. And what we want to cover is kind of starting from the paper that was published with um, Sandy Pentland and Scott Page and John Seely Brown and Martin Reeves, which kind of outlines the framework in general, which we believe this is going to be more than one company in this category. The purpose of this video is to describe a research environment that has been under construction for the past 10 months. And it implements a full agentic architecture, and it's a next generation beyond CrowdSmart 1.0. And so this is not to be the UI. So think of this as the architecture and functionality. UI is going to be in development. We'll say a little bit about what the thoughts are there in the back end versus the front end. But fundamentally, this is the first of a series. And so we're going to do an overview on this one. This one, we're going to focus largely on using the new environment for a collaboration or a jam with humans alone. What we are talking about with generative collective intelligence, and this is very important, you guys, picked it up in the paper, but this is a different way of looking at AI as an orchestrator of our collective learning together. The output is an AI model. It isn't about constructing or using AI to construct an answer from, say, prompt engineering or querying an existing large language model. This is using large language model capabilities ultimately in the process of instrumenting and helping human collaboration. So what this approach, and we're going to first start with an all-human team to emphasize that, and this will be a carryover of a type of thing that we did in CrowdSmart 1.0. And then we'll, towards the end, move into what does this mean in terms of working with agents. Like I said, there's a lot here, so this is going to be the first in a series. So basically, the reframing that generative collective intelligence states is that AI is not an answer machine. This is not something you prompt engineer. This is something where we're going to be using a AI as a collective reasoning agent using a very different transparent learning model, an adaptive learning model that's largely based on um, principles like partially observable Markov decision processes, particularly and specifically as one would see in the free energy principle and active inference. But it's also kind of a it's a bit more than just that alone. It actually is a marriage of thoughts in collective intelligence with adaptive learning. So again, it's going to be about orchestrating human judgment with AI ensuring rigor, scale, and learning. Now, the basic platform, and we're again just going to look at the human expert participates in it first, is functioning like an operating system. And like everyone else, I'm a little bit hesitant to use that word, but in fact, in this case, it really does organize knowledge and produces as output an automated knowledge model. So it's an automated knowledge acquisition system that can say, take what a group would predict, look at their reasoning process, and then test it against ground truth. So the inputs are coming from human experts. In this first one, the outputs will be a very special kind of language model. And we'll talk about why it's special and then talk a little bit about the reporting on that. So, how it works is we bring a group of people together. In this case, we won't engage AI agents. We create a collaboration. I also call them in this environment jam because I'm really emphasizing the fact this is about adaptive learning brainstorming, bouncing ideas off of each other, looking for serendipitous discovery. The collective reasoning process it was invented as a way of looking at the reasoning that goes on when a group of people are making a collective intelligence prediction. Fundamental principle is that the collective intelligence predictions from a cognitively diverse group of subject matter experts will be more accurate than any single expert. So the output we'll get is a model and of two forms. One is a queryable language model that reports out the collective voice, and the other is a causal model, approximate causal model that comes from the reasoning process. The guide to this is think of it as a group script or prompting manager, and we'll show how that works a little bit. So the application focus here is going to be answering the question, if we make a decision, for example, in this particular case, we'll look at an investment decision. If we make a decision, what is the likelihood that that outcome will be what we expected? So in the case of making a decision on investing on an innovation or a startup, it would say, if we invest, is this investment going to return a value to us? Now, we can't look at long-term value, but one of the principles we can look at is that any innovation, if it's going to create a return, has to be able to create progress that points to the ability to get additional funding. That is, the entity can stay alive and further develop. That's the fundamental problem we're going to look at here. So, the participant is provided with information, in this case, startup information. The participant is asked to make a quantitative estimates. In this particular case, they're going to be looking at the business case, the team, etc. So that's what we mean by a multi-criteria model. The participant then is also asked to provide their thinking, their reasoning that led, their five whys, if you will, that led to that score. Why? Why did they think the team was good? Why did they think the business model was good? And it's very important that this is just free thinking, and it can also refer to articles or other evidence if that's appropriate. Then the participants' thinking at that stage is actually mapped into a language model. And we'll talk a little bit about how we use transformers somewhat differently than is done in a large language model training. There you're looking at just vectors from a set of documents. Here we're looking at the vectors themselves are curated. So when this goes in, even from that participant, we know who the participant is. We know what question they're answered. We know a lot about what they've been exposed to up to that point of creating their statements. Um, the other part of this is the participants are then shown a sample and assume that the language model where the vectors are put in, there's others in there from other people or a seed that's been put in there, and they're now shown a sample of others' reasoning and are asked to respond to that in terms of does it align with or do they feel like no, it's not applicable at all. So getting their response to the reasons that are being proposed for scores. And here, this is about figuring out what is the evidence that we can learn, what is the causal underpinning that we can learn from this. And then the system keeps track with an evolving memory that will influence the future participants. So each participant will see something slightly different because it's adaptively learning from the process. Now, I mentioned this is a special kind of language model. This is actually, a much higher dimensional model, but I'm just showing a 3D image here to show that what we are doing is annotating these high dimensional vectors going into the language model. And we use that way this is laid out, and we actually model this as a semantic Hilbert space. So we're using transformer models as simply a way to manage the deliberation and dialogue process of people reasoning together. Uh, Again, take a step back a moment and think about that. We're not using the language models to say, take a whole bunch of data and see if we can have it perform well in a Q&A experiment. We're fundamentally now looking at, can we construct a model that highly contextualizes the context. I mean, the highly contextualizes the what those particular statements mean. What question were they answered to? What was the attitude associated with that? In other words, did individuals were they leaning into the, say, giving it a 90% or were they giving it a 2%? All of that can go into this. And this is all done with time series data, so we can look at the evolution of the system. Now, as I mentioned, this is not the final UI, but we'll use this to illustrate. What is constructed, and this is constructed within the system, is all the participants. In this case, we have 17. And in general, while the back end knows identity, when people are involved in reasoning with each other, we mask the identity in much the same way that in the peer review of literature in a scientific publication, we basically, the identity is masked in that process. Same idea. What we are attempting to do here is mirror the review process associated with scientific research. And so that kind of is the most dependable way we know of really getting to alignment on the underlying knowledge. And here, uh, consensus is very important when you're talking about evidence, whether it's evidence in science or evidence in a court of law. You want alignment. This is not groupthink. You want to know, are people agreeing on the evidence? That's really what it's looking for. Now, the lines that connect the different participants shows where they have shared knowledge, where in this particular case, Salvador may have rated a or agreed with, prioritized something that was produced by someone else in the collaboration. Now, next, before the participant even engages, the participant is given an opportunity to get familiar with the materials on, in this case, a startup pitch deck, etc. And they can query this via what we call a research agent. This is basically a knowledge agent that is purely vectorized documents that were provided by either the evaluating team or the startup team or the investor team. This is the repository, and it does not go out to an LLM. It is basically a repository of knowledge very specific to this particular use case. Now, again, the next step then is the user is given a panel where they are now are looking at the various queries, the prompts, and they're asked to give their response, given a slider, and then there's a box for them just to put in all of their reasoning. They are then, this goes across the board. They notice also on this panel, they can go to something called an idea jam, where they just can actually interact with the ideas and get more familiar with what is the thinking process going on. So think of this as kind of like a super Slack or a super Reddit or super Teams discussion, any kind of a discussion environment where we're both looking at the sharing of information, but then an understanding of the peer-reviewed relevance of that information to the outcome. Now, in the peer reviewing process, they're able to indicate they like it, like light bulbs, one, two, three, could be more. And we can provide various forms of getting that prioritization. But this is really fundamental. The more we can know the ranking, the citation ranking of the other participants information as opposed to in conjunction with my information, the more we're able to learn. So the system is learning from the deliberative interactions of people thinking together. So this interaction information is extremely and critically important to the overall process. There is also an ability to go and join in an idea jam. And this is where a participant can go and they can flag a piece of information as maybe misinformation. They can ask a question, say, what do you mean by this? And that will send a message to the participant and they'll get a reply. They can also hit that thing on the right, a wrench, and build on someone else's idea. And that provides a capability for doing like a serendipitous discovery. Oh, I see your idea. I want to add on it. Someone else can add on that idea. So we keep track of the evolution of ideas as they kind of go through this idea collider and are built on, people can build on each other's ideas. Now, at the end of the day, the participants are now able to query the collective voice. What is the collective voice? Well, this is where I said the language model is quite different because this particular uh, language model is very highly annotated with context, with a probability that this is of relative importance to everyone in the group versus not. So there'll be a probability distribution of relevance to as peer reviewed by the group to the outcome. So this is contextualized. It is also has a collective view on it. That's why we call it the collective voice. Therefore, when we ask a query, even though the data model may be small, this is not, I think you saw in the prior screen, this may be 40 or 50 vectors. Even though it's small, because it's highly contextualized, it can be rich. And so here I just asked the simple question, what are the risks? And if you read this, you'll see that it's pretty precise. And it also then refers to the commentary, specific sources that led to that. And those sources are very specifically what people have said in their review process. So think of this as creating a highly precise record of the interactions of the group about a complex decision. It also will produce a Bayesian belief network that indicates what the current score is, meaning it roughly the group is thinking this is an 88% probability this company will get further follow-on funding. And then it gives all of the themes that are going into that, the reasoning going into it, um, and gives you all of the background on that. Um, Now, in addition, because we have such annotated vectors that have these concepts with them, we can now begin to look at things like semantic similarity analysis, where we can look at the degree to what happens over time. We can look at co-creation potential. We can look at causal potential. In this particular case, we're looking at the causal relationships, and there you see at the top a one that this is not strong, but there is a potential causal relationship that has been extracted. So this metadata allows us to build all kinds of back-end graphical models of the potential underlying structure. Now, that is the basic thing for an all-human group. What we now will cover in a further video is how do we extend this to agentic. The entire new architecture is built on an agent interface environment type architecture, which is basically says an agent can be a human or it can be an AI agent. These AI agents can be of various forms, as shown in this uh, graph. They can be a foundation model agent where you could say, hey, let's have different foundation models answer the same set of prompts. What we call as a knowledge agent is an agent that is like the research agent you saw, where it's only reasoning from the knowledge that we give it based on a set of documents. So it's highly curated. But the knowledge agent can also have a belief, desire, intention loop where it's going out and updating its knowledge base if we wish to have it do that. We can also have autonomous agents that can do tasks like fact checking or whatever. These agents can either uh, run autonomously, or they can participate in the orchestration process that we just showed, where they are actually participants in a collaboration along with humans, where they will answer the questions, give their predictions, give their reasoning. They can even rate and rank and cite each other's reasoning. So this is also a way you could do an agent only situation. We can talk about that in a future uh, presentation, but we could do an agent only thing where we could actually look at, well, how do different model agents respond to the same prompt? So this provides a way to orchestrate, integrate intelligence of a group of interacting agents, be they human or AI. And as you will see from the paper, and there's a supporting math paper to this, this is done in a somewhat deep, mathematically sound method of knowledge integration that very closely follows sort of the scientific knowledge discovery process. So the role of knowledge agents will be like research and knowledge agents can be, again, assistant. Think of all the data you might have in an enterprise or about a company that can go into the research agent that will help with all the participants having all the data at their fingertips. The knowledge agent can also be one that represents different, for example, it could be all the collection of papers of a particular individual. It could be a company expert that has written much internal documentation on how a system component works. So think of knowledge agents of a way of taking crystallized cognition and expertise and bringing it into an active collaboration with other human beings. And in the same way, they can participate in idea jams as well. So this is basically the idea. There are some other papers that support some of the theory behind this, but this could give you a quick overview of what generative collective intelligence is about. It is a system to aid in dynamic learning between humans and AI agents together. That is the idea. It produces knowledge models that can be then deployed, automated in different ways. But so you can think of this as a way to integrate uh, the use of AI agents and the agentic world into human decision making. Now, one of the fundamental things we get out of this is a sense of trust. We can move from plausibility being generated by AI agents to trusted intelligence. It's highly curated, highly contextualized, and we can actually have a system of record of how certain decisions or investment decisions are made. This can create a system of record for that. Thank you very much.